Welcome to this tutorial on dynamic analysis in Flexcom. My name is Angus Conley and I am the product manager for our Flexcom software. So now I'm going to show you how to build a time domain dynamic simulation in Flexcom. And this is very straightforward, as we've already built the model as shown in the model building tutorial which you've watched previously. So I'm starting from an existing model. It's a static analysis of a steep S riser. So I'm going to begin by adding a new file. It'll be a metric file. I'll just call this one dynamic KYXM. So I have a brand new dynamic file. The first thing I'm going to do now is insert a load case section. So the model section is already built. We already are starting from a predefined model, and now we're simply changing some environmental and loading conditions and boundary conditions and time domain solution parameters and so on. So the first thing I will do is I will set the analysis type to be time domain dynamic, which is the first one on the list. Next thing I will need to do is to insert a restart keyword. The restart keyword is quite important in that it links this new simulation to a previously performed static simulation, which I've already got here, which is called K1SWR static. I'd also like to maybe define some wave loading. So I'll put in a regular wave loading for simplicity. Amplitude, let's say 1 meter, wave period 10 seconds. I can leave the direction and phase angles as both 0. So at this point it might be useful for me to define a parameter as well for the wave period, and you'll see in a moment why that becomes useful. So I'm going to insert a pre-processor section, define a new parameter. Again, you're probably very familiar with this now at this stage from the earlier tutorial. So I've got a wave parameter, period parameter called t. I'm going to reference this t parameter from my regular wave keyword. And the advantage of doing that is that I can reuse that parameter now when I define my solution time variables. So I'm going to define a variable time step algorithm. I'll start the analysis at time 0. I would like to run it, let's say, for 5 times period. So regular wave simulations, you run them for long enough to reach steady state. A ramp time, I'll just use a single wave period as the ramp time. In terms of my suggested time step, let's use maybe about 5% of the period. So this is useful if you want to use a template file later on. So we'll come to that later. The minimum time step I'm just going to set as a very small value. The maximum time step, again, I'll just say as roughly about 5% of the wave period. So while we're just running a single regular wave analysis in this simulation, I'll show you in a future tutorial how you can actually use this to be a template file where we can actually create lots of different waves with different wave periods, and the time variables still relate back to the wave period itself. That's pretty much all the information I need, really. I might just bump up the regular wave amplitude so we can see the motions a little bit more clearly in the animation. And I'm just going to right click on the dynamic simulation and hit the run button. So you can see in the analysis status window the simulation has just kicked off. And it'll just take a few moments to run. It's a regular wave simulation, so it should run quite quickly. You can see the time variables here. It's going to take about a half a minute to complete. So let's just wait for that to complete, and while it's running you can actually see that the model view has now become updated, so I can actually start to play back the model if I want and watch what the response is like. So you can see the wave movements there, the vessel is moving in response to it, the riser is responding as well. Maybe I can't actually view the stress parameters yet because the simulation is still moving, but that's quite a clear picture there, so you can see the vessel clearly moving up, heaving, pitching in response to the regular wave loading. My simulation is fully completed. So it's literally as simple as that for a dynamic simulation in Flexcom. As I said, the majority of the effort is involved in constructing the model itself, constructing the geometry, applying structure and hydrodynamic properties, defining the vessel, adding the vessel REOs. And when it comes to doing a time domain dynamic simulation, really it's very easy. All you need to do is define the analysis type, which is dynamic, the file that you're restarting from. So we're restarting from a pre-constructed model which we've reached static equilibrium with, and then we're defining the loading, which would be regular wave loading in this case, and some solution time variables. So very straightforward. If I wanted to do a random C simulation rather than a regular wave, I just simply comment out this regular wave keyword using the comment button on top, and I'd start to type in, I'd select the random spectrum, be it like Pearson Moskowitz or John Swap or whatever, and start choosing the discretization for that type of spectrum, and then specifying HS and TZ. So it might be something like a 2 meter wave with mean up crossing period. I'll just use the same period here again for simplicity, and some other variables there to do with how the spectrum is discretized as a function of frequency. Let's say I might use 100 harmonics to do that. So I'd have one wave direction, a unidirectional Z state, dominant direction of 0 degrees, consistent with the regular wave. If I was to do a Pearson-Moskowitz spectrum rather than a regular wave, I just simply modify my time variables here to, instead of running for a few periods, I might run that for 3 hours. So it might be like 10,800 seconds. And that's as simple as that. So that's a time domain regular wave simulation. If I wanted to do random C, I'll just remove the regular wave keyword. I'm not going to run that now because it would take quite a long time to run, but what I could do if I wanted to was just to change this to a frequency domain simulation in Flexcom, because you can use time or frequency domain solvers. And if I switch to frequency domain solver rather than a time domain, then I just need to remove the time variables because they would be irrelevant in a frequency domain simulation. And again, I just hit the run button. So that concludes the tutorial on running a time domain dynamic analysis in Flexcom. In subsequent tutorials, the next one I'll show you how to actually post-process. I like to keep the tutorials relatively short so you can watch in little blocks. So the next tutorial we'll actually see how we extract some results using database or summary post-processing, and we'll have separate tutorials to cover the model view itself, which you see on the right hand side here, and indeed the plotting module to show you how you can extract some results. So we'll leave it at that, and I'll see you in the next tutorial.